So you might be wondering what this might be. It looks like nothing much, just red dark liquid in a clear acrylic tube mounted with ball bearings. But wait till you see it spinning in action.
What's this? When spun, a zigzag line appears. This is a phenomenon called the sawtooth instability.
Do we see this in our everyday life? Not very often, you would think. The question here lies with this liquid over here.
So what is this liquid made up of? 60% corn syrup and 40% water, plus 3 drops of dye to make the phenomenon clearer. What's so special about the corn syrup water mixture then? Corn syrup is not anything like water. Even though they are both clear and transparent, they do have different properties. Now, corn syrup here is what we call a viscous fluid. Viscous fluids resist movement, so when I tilt this bottle of corn syrup, it actually moves quite slowly as compared to water, which sloshes around. Viscous fluids are sticky. They also like to adhere to different objects with strong adhesion forces. So when I stick a wooden stick in, a lot of the liquid is pulled up along with the stick. However, in water, no matter how hard I try, the water just doesn't come out with the stick. Viscous fluids such as these exhibit many different cool phenomena like kinetic reversibility and Rayleigh instability, but that is for another day. Going back to the stick in the corn syrup, here is a free body diagram. As we can see, friction plays a very important role, especially in adhering the liquid to the stick, so it flows much more slowly downwards compared to non-viscous fluids like water. So what does viscous fluids have anything to do with whatever we just saw? Now, I want you to think back to the last time when you were painting the walls of your house, giving it a fresh new look. You might have noticed these unusually large droplets standing out in our sometimes uneven coat. Here, we can see what we call a fingering phenomenon when we have a fluid flow down a plane. Due to instantaneous thick and thin in the fluid experiences unequal amounts of friction per unit volume. Thicker ones therefore move faster than the thinner ones. When they start to move down, the faster ones start dragging more material from the others, making them thinner and slower while the droplet becomes thicker and faster, until eventually it cannot do so anymore and it stops. This phenomenon is more visible in viscous fluids. Going back to the sawtooth instability, how is it related to the fingering phenomenon? Such properties of the liquids can be explained similarly to the fingering paint phenomenon. The nice pattern of the sawtooth instability appears as such instead of the fingers that we see for paint is because it is confined and is in constant circular motion. Also, we can see that at a constant angular velocity, it will eventually settle into such a shape, with all the forces adding up to the resultant centripetal force, which is directed towards the center O. When experimenting with different angular velocity, we can see 3 different phases occur. At 0 angular velocity, the fluid is stationary and remains at the bottom of the tube due to gravity. At a high angular velocity, coating flows occur. This is where we see the thin, homogeneous film of liquids forming onto the surface of the tube due to centripetal force. Any speed in between, gravity no longer adversely affects the liquid, and thus we see interesting phenomena, one being the sawtooth instability.
Whew, that was a lot to take in, wasn't it? Here's a quick recap.
Here are the 3 main points of today. 1. A viscous fluid is one that resists movement or the movement of an object within itself. Number 2. A fingering phenomenon is a phenomenon whereby different parts of the fluid flow at different speeds down a plane, resulting in the formation of fingers, like what we saw just now. Last, but definitely not the least, the main point of the day is that sawtooth instability is a phenomenon that is a result of interaction of forces like inertia, viscosity, and gravity. This only happens when the fluid is of a certain viscosity and when the cylinder is rotated at a certain speed.
I hope you enjoyed the video and thanks for watching!